Every time we make a phone call, stream a video, or send a message, invisible microwave links make it happen. But how do engineers decide where to place these towers or align communication paths?
Our goal is to design a point-to-point path profile. To complete this path profile, we use several tools: Google Earth Pro for mapping and visualizing terrain, UISP Design Center to simulate wireless links, GPS Visualizer for converting data into appropriate format, and Microsoft Excel for computing parameters like Fresnel clearance and total height extended. We will demonstrate each tool later, but first we need to understand the technical aspect of planning cellular towers. The Journal of Planning for Cellular Towers by Ben Campanelli is one of the substantial materials that I have read. Ben Campanelli recommends a regional collaborative approach to cellular tower planning that includes mapping existing structures, prioritizing preferred land uses, and maintaining a shared database of potential sites. He urges regions to host public workshops, require providers to submit annual network plans, and develop clear siting and design criteria. Ben Campanelli explains that wireless networks are organized into geographic cells, each served by a base station and arranged in a hexagonal grid to ensure seamless coverage. Within each cell, providers define a site ring, a focused area where they must secure a suitable location for antenna and equipment. These rings guide acquisition teams in identifying viable structures or parcels, especially in high-demand zones like highways and commercial districts. To address aesthetic concerns, Campanelli introduces stealth towers, which are camouflaged to blend into their surroundings, such as being disguised as trees or flagpoles. Though more costly, stealth towers can reduce public opposition and legal delays, making them a strategic investment for providers seeking faster approvals and better community relations. He also emphasizes the importance of co-location, where multiple providers share a single tower. This approach minimizes the number of new structures required and can be encouraged through incentives such as tax abatements or expedited permitting. Campanelli recommends that planning agencies require certification of co-location capacity and prioritize shared-use towers in preferred zones to streamline deployment and reduce visual clutter. With this in mind, we move on to finding potential sites using the features of Google Earth Pro. We need to investigate the capabilities of the site to provide electricity and water, its accessibility by road, and its elevation, which is important in establishing a clear line of sight between the stations. We must be vigilant of obstruction and the possibility of interfering the clearance. A total of 11 paths were surveyed. The usual problem among these options is they are either blocked by a hill or the link is less than 10 kilometers. Fortunately, we have spotted a Globe Telecom tower at Masarawag, Ginubatan, a kilometer away from my residence. I knew that building the cell tower is possible because of the existing guide tower nearby. For the receiver station, we wanted to transmit the signal to Pulangi, so we scanned the area and saw the hill facing the station. It is in the jurisdiction of Barangay Ponso. Our first option was to put the tower on the top of the hill. However, we have difficulty finding a power supply and flat ground. So we scanned through the area and found the cell sites. Here we established our final site location. From there, we can visualize the path profile and conclude the parameters using Microsoft Excel. However, in our opinion, eyeballing the values of elevation and distance of the path profile is difficult and unreliable. Hence, we opt to use another software. UISP Design Center enabled us to accurately map the properties of the path between Station A and Station B. It has also enabled us to choose the initial height of our antenna. Next, we convert this KMC file into text using the GPS visualizer. The text can be imported to Microsoft Excel, and from there we can extract the elevation and the distances of the points along the path. Here are the formulas we used in Microsoft Excel.
This means finding the best line of sight connections between two stations, while accounting for the terrain, obstructions, and zoning considerations. It is a task that mirrors what real engineers do. It starts with mapping and ends with decisions that can shape communities.